All right, Chapter 7 test. For those of you who need to go back over this, let's go over these problems. Number 1, find the following probabilities. So we got to find the probability, state whether it's theoretical, relative frequency, or subjective. And then we got to explain. Well, if a batter gets 0.029 not by knowing equally likely and whatever it is, all we can do is notice how many times he's gone to bat and how many times he's got to hit and figure out how frequently he gets a hit for the number of bats. And so this is relative frequency because we're basing it on the batter's history or prior experience that we have. So there we've decided this part, and now we have to do the probability. Well, getting 2 hits in a row, it's 0.29 chance, 0.29 times for the first hit, and 0.29 for the second, which is 0.29 squared, which works out to be, I've forgotten, so I'm going to pull out my calculator here. It's going to be close to 0.09. Let's see here, 0.29 squared. 0.0841, which I should round off to 0.8. But that would be the probability that you get 2 hits in a row. Tossing a coin and getting 3 tails in a row. Well, since we know the probability of a coin is 50-50, we're not basing it on any history now. We just know that a coin is supposed to be a fair and 50-50. And so we can calculate all the possibilities. And so theoretically, it would have a 50% chance ahead and 50%. So this is a theoretical. Based on coin having only 2 outcomes with both equally likely. And to get 3 tails in a row, the chance of getting a tail on the first one is 1/2. Chance of getting tail on the next one is 1/2. And on the third one, 1/2, or 0.5 to the third, or 1/2 to the third. 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8. Now, what would be subjective? Where that would be where someone just kind of makes up what they think the probability is. Like someone gets up in the morning, looks at the sky and says, oh, I think there's a 30% chance of rain. They're kind of basing it on their experience, but they don't have any data, so it's not really relative frequency. It's just a personal, probably a learned guess. So often that's what happens. And for instance, if you're a good bettor on horse races, you might say, oh, that horse is going to win. I think it's got a 50% chance of winning. That would be subjective. Now, if you took a lot of data on the horse and based it on the data, then it would have been relative frequency. All right, number 2. She's picking out her summer dress and her accessories randomly. She has 4 dresses, a pink, a blue, green and a yellow. Nice that they're completely different colors, so we can draw that. And she has to decide whether to wear a necklace and earrings or none. So when she's deciding whether to wear a necklace and or earrings, then it could be just like the condiments. You either have a necklace on or you don't have the necklace on. You have a necklace on or no necklace on. You have a necklace on or no necklace on. And then you can put on the earrings or not. This one goes to there, there, this one goes there, and there, there, and there, there. So that's 2, 4, 6, 8, 10, 12, 14, 16, or 4 times 2 times 2, 16. So there's 16 outcomes. What's the probability that she wears earrings and a necklace with her dress? So that's both. That's with the pink dress, or with the blue dress, or with the green dress, or with the yellow dress. That's 1, 2, 3, 4 out of the 16, which is 1/4. Or you could think of, well, she could wear earrings and necklace, earrings, no earrings and necklace, no necklace and earrings, or no necklace and no earrings, and so that means there's 1/4 chance on each dress. What's the probability that she wears a green dress, or, so green dress, that's 1, 2, 3, 4 outcomes, or has a necklace on? There's 2, 4, 6, 8. But I've counted the overlap and I got to subtract that. That's green dress and a necklace on. Green dress and necklace. There's 2 of them that I've counted twice. So that's 12 minus 2, 10 out of 16. 5/8. And finally, what is the probability that the outfit is pink or yellow? There's no way it could be both, so I don't have to subtract overlap on that. So pink is 4, yellow is 4, so that's 8 out of 16. Or she doesn't have earrings and a necklace on. Doesn't have earrings and necklace. So that means she could have had nothing. So then that would have been this one, this one, this one. Doesn't have earrings or a necklace on, and a necklace on. So that's, I got to throw those out. That's 1, 2, 3, 4. Or no, add those on. Doesn't have earrings. Doesn't have earrings and necklace on. Doesn't have earrings and a necklace. So that would be. Oh, so that one. That one's that one. So the only one I gotta rethink that there. Doesn't have earrings and a necklace. That's both of them. So that one counts, that one counts, and that one counts. Because those 3 don't have a necklace and an earring. So don't have a necklace and an earring is that one. So I can't use that one. So it's 3 there, 3, 3, and 3. So that's 12 out of 16. 8 plus 12, but minus the things that I've counted twice. Pink or yellow, there's 3 there and 3 there that I've counted twice. That's 6, so I got to take away the 6 out of the 16. So that's 20 minus 6 is 14 out of 16. I may have scored that one incorrectly on your test. So if you had 14 out of 16 and I didn't catch that and you're watching this video, see me. Okay. Imagine a game where you draw a random card from a 52 card deck and then without replacing it, draw it again. What's the probability, and you do that 3 times, what's the probability of getting at least 1 heart? That would be 1 minus probability of no hearts. And the way you get no hearts would be the first draw you would have to get a non-heart. Since there are 13 hearts in the 52, there's 39 non-hearts out of the 52. If you don't replace it, there would only be 38 non-hearts out of the 51 left. And if you don't replace it, there'd be 37 non-hearts out of the 50 left. And if you want at least 1 heart, you would have to take that and subtract that, so that would be the 39 times 38 times 37 divided by parenthesis 52 times 51 times 50. This part is 0.41, and 1 minus 0.41 is 0.59.